put this together. You know it's going to work for the processor. And if you mix and match other devices, it's kind of risky as a designer. It could work. It's going to delay your time to market, I think. So, to have a full solution is a big, big plus for a company like Intel.
Good point, Steve.
Yeah. And, timing is just right because Intel just on July 1st at the IFA conference in Europe, in Germany, announced Skylake. We're right there with them, ready to go to market. So you're going to be seeing 2-in-1s, tablets, and ultrabooks coming to market very, very soon. With powered by Intel, and we power Intel.
Yeah, no, that's nice. That's really a good thing because Intel has no power unless you give them the power. So that's true. And of course, I'll respect the embargo until September 28th. That's not a problem.
Okay, appreciate it. So, with that introduction, I'll go ahead and turn it over to Ja. Oh, and by the way, Starry Sai just walked in the room.
Hi, Steve. How are you?
Oh, great, Starry. Thanks for joining us. I appreciate it.
Yeah, thank you.
Okay. All right, over to you, Ja.
Okay. So, Mark, Steve, can you see my computer screen? I'm sharing.
Yep, I got it right up here. It's very clear.
Okay, great. So, Steve, today we're going to be talking about the computing segment solutions, but actually at intersil we do more than just a simple computing, as we do address a complex power system in mobile devices, meaning it's not just computers, we also do handheld devices,
no problem.
We also do tablets, we do all kinds of things, anything that's battery powered, we can say we have solutions for it. That also includes like the display and backlight drivers, as well as optical sensors. That may not be totally power, but that's also part of our product offerings within intersil mobile power business unit. Although today my focus is still on the more traditional computing power. I just want to make you aware that what we do.
That's great. I appreciate it.
So you already hit the nail on it that we had a long history in this market. So here is just a little summary of us and our competition in this market. This computing market, it's been there for a long time. This chart will only show the last 10 years. If you read it, we didn't name the competitors, but competitors come and go. Intersil has stayed in this market, committed to this market, and we plan to stay in this market for any foreseeable future too. And you can see that other competitors are not totally committed. They may come in when they think it's profitable, when they think they can compete. When they cannot compete, they simply quit and leave. So we're seeing that it's a revolving door. Different companies come and go, and we are the only constant in this industry. That's because we have the technology, we have the knowledge, and we know how to work with Intel efficiently to make sure that we can power them to power the whole computing world. And historically, if you look at it, Intersil, we have had very strong market presence. Our market share does vary from platform to platform. That's strongly influenced by the number of competitors in the market. That's naturally the result of competition. Now that the market is less crowded, some companies already left. Our market share, we're not disclosing our market share for this upcoming Skylake platform yet, but it's actually looking pretty good.
It makes sense. I know, companies like Intel, first of all, it's hard to become an approved supplier for a company like that. But, I know that they value somebody who's serious about being there in the long term. And it's like the automotive industry, same kind of thing. And I know that, you guys are going to do well there because that's reliability as far as a supplier goes, that you're going to be there over the years and to support them.
That's right. Yeah, especially if you look at the last row of the table, that's what Intel uses on their reference design. Historically, Intel has always used Intersil, except for 1.5 platforms that it didn't choose Intersil. And actually, that competitor entered the market briefly and left Intel in a very awkward position. So Intel has regretted that. And the latest Skylake generation, Intel is again using intersil solutions as a reference design because they realize that intersil commitment to the market is very important to Intel's success as well.
Right, exactly. Yeah, there'll always be competitors, and of course, Intersil always wants to have somebody in their back pocket as a backup. And but I mean, your track record says it all. It just speaks for itself.
Yep. All right. So Mark touched base on that. Intel recently announced the Skylake generation, and it's a very, very good performance processor. I can see that. It's Intel obviously has much more knowledge than what we know about their processor performance, but it's being advertised to show faster wake-up, longer battery life, and optimize to run Windows 10. I have every reason to believe Intel's claim on that. The key is, for the last few years, the computing industry has not been as exciting as we hope it would be. Therefore, people have delayed the computer refresh and waiting for something exciting to happen. We believe the Skylake generation coupled with Microsoft Windows 10 will excite the market to replace the older PCs that are out there. I mean, I have older PCs at home that are even more than 5 years old, and I think they're due for a refresh. We do see this opportunity to offer an innovative solution because as end users, these days, I'm not just looking for another computer that runs a faster CPU. I'm actually looking for a lot of different features that will bring tangible benefits to me as an end user in addition to faster calculation speed or processing speed. I'm looking for mobility, meaning it needs to be thin and light. It needs to have longer battery life, better be as long as like a whole day, so I don't have to charge my computer. So all these things have posed new challenges to power solutions. We can't keep doing the old-fashioned way. We have to innovate. So at Intersil, we have realized that we have invested in the new power solution trends to provide more innovative solutions than just another power solution. So the two key things we are talking about today are, one is what we call a core PMIC, the ISL 95852. This is a core PMIC, meaning it's powering the Intel CPU, and it comes in what we call a power management IC. That means it's a highly integrated solution. The other product is an ISL 95520. That's a battery charger, so it's not directly powering the Intel CPU, but it's powering the whole platform, including the vCore PMIC. So between these two, we are offering a set of solutions. And Mark also mentioned that we have a peripheral power PMIC, or you can call it a subsystem PMIC. Between the three sets of PMICs, you have a whole platform solution that covers everything you may need. So there are a few innovations we put into these products is, first of all, the 95852 is the industry's most highly integrated solution. You cannot find a smaller solution in size than this one, period. It's leading competition by a mile. It reduces the motherboard space dramatically. The way we did it was we integrated everything, meaning the controller, the power FETs, the gate drive, and the monitoring feature, protection feature, everything into a very small piece of silicon. It actually comes in a 4 by 4 millimeter in size. So it's very tiny, yet it can do everything. Because of the high integration we put into the chip, we can do a faster switching frequency than competition. Today, a typical solution will operate at 400 kilohertz to 700 kilohertz. And with integration, we can operate at up to 1.3 megahertz efficiently. Therefore, you can use not only a smaller silicon piece, you can also use much smaller passive components, meaning the chokes, the capacitors. Therefore, you have the smallest possible board space, and our customers value that.
Yeah, running over more than a megahertz is good. Is really good because, like you said, it just knocks down the inductors and capacitors and stuff like that in size.
Exactly.
Now, let me ask you a question. Could you give me just a quick, brief overview of hybrid power boost and narrow voltage DC? Just generally, what's the meaning?
Yeah. I have a page. Let me skip to that page so you can see a little more visual description of these two. This is related to the whole platform power architecture. When you have an adapter and you have a battery pack, there are two different ways of configuring the system voltage. One way, people call it a hybrid boost. That's an Intel name. The system would get the voltage from either the adapter directly or get the power from the battery. Therefore, the system will see a varying bus voltage. Actually, the range is quite wide. A typical adapter would be 20 volt. A battery, if it's a 2-cell battery, the voltage range is typically between 5.5 to 8.4. As a result, the system can see a voltage range of 20 to 5.5. It's very wide, and obviously you have to design the whole system, all the downstream converters and everything, according to that 20 volt rating. And as a narrow voltage DC, the system gets the voltage directly from the battery, basically all the time. The switcher will just charge the battery as well as providing the power to the system. Therefore, the system can only see the battery voltage. In the same example, the system bus will only see 5.5 to 8 volts. So there are pros and cons between these two architectures. A significant advantage of a narrow voltage DC system is the technology for integration at a narrower voltage range is significantly more mature than trying to do so with, for example, 20 volt system bus. At a max 8 volt system bus, there are a lot better ways to do integration, much like the product, the CPU core PMIC product we're talking about today. We can use a monolithic integration to combine everything together. And same cannot be done easily or efficiently with a 20 volt rating.
Okay, that's great. And I see you can actually do a co-layout to have the possibility of having both of those. Maybe in some cases they might want to do it one way, in some cases a different way.
Exactly, because there has always been this debate of which architecture is better. And debate is a good thing, otherwise you would have seen just one solution today. Because narrow voltage DC, it does have this disadvantage. The problem or disadvantage of a narrow voltage DC architecture is on the inductor and the switcher in general. The switcher would need to provide the battery charging power in addition to the system power, meaning you have to scale the switcher with a higher rating, current handling capability. Some people don't like that. While in a so-called hybrid boost system, the system can get the power directly from the adapter, and the switcher only needs to handle battery charging. So there is this debate. Many people cannot make up their mind, and therefore you see different solutions out there. People do a lot of study, which one is better. There has never been a definitive answer until today, because we tell people, hey, it has to do with your system need and the configuration. The best way to settle the debate is, why don't you use what we call a combo battery charger that can be configured in either way, and you can do a co-layout. Therefore, you can try both architecture on the same system, same board. Whichever is better, well, that's your solution. You can settle that debate and just pick the best fit for a system. People like that. They now have just one solution they need to learn, and they can use either way, depending on their need. So this has been a very good feature a lot of people like, and it's industry's first, because nobody did it in the past, including intersil in the old days. companies will simply have to offer 2 different families of battery chargers to support different architectures.
Right. Very nice. That's very nice. Again, thank you for that explanation. It's very, very clear now.
Okay. All right, so we didn't finish this page, but we sort of finished it because we already talked about this combo charger. So all these products, from V-Core to battery charger, I should point out that they are based on intersil's patented, what we call a R3 modulation technology. This modulation technology is best in class. It has been that way for the last decade. It started in the CPU core regulator market, but we have successfully converted to the battery charger market as well. So now all of our products run on this. We keep improving it in the last decade. So it has maintained this advantage. Therefore, you can get better light load efficiency, which means battery life, and also faster transient response, which means less bulky solutions. And this has translated into tangible benefit for customers.
Now, would you have any kind of a small overview of what R3 modulation technology is, or a white paper? Because I know my readers, the audience would be very interested, and I think it would be a benefit to them to understand why this technology.
Sure. Yes, we do. We do have material like that. It's not in this presentation today, but we can definitely provide that.
Yeah, that'd be great. Just kind of a short little overview of what it is. That'd be fine.
Sure. Yes.
Yeah, Joe, if you can send that to me, I'll forward that on to Steve, or if it needs any editing or any modification, I can work with you on that and then get it over to Steve.
Sure, no problem. Yeah, I have the material ready. You're not the first one to ask for information on that.
Okay, great. Yeah, that'd be really interesting.
Sure. So a solution, this is, again, the CPU core power for Skylake generation. A more discrete solution, as we said, it's running at 700 kilohertz as the highest. A Skylake generation CPU requires 3-volt rails. Intel calls it IA, GT, and SA. SA is system agent. Therefore, we need to provide 3-volt rails, and in this case, it's each phase, not each rail is a single phase. So that is the lowest power solution. Intel calls it a Y-line CPU. If you do it a discrete way, the power solution size is the estimate we put in there. It's about 340 square millimeter. If you do it the 9552 integration way, you can see that we are doing all the silicon in just a 4x4 package, and everything else is just passive. The inductor is smaller because of the higher switching frequency. The output capacitor is less because of the higher switching frequency and faster transient response. We can significantly reduce the solution size. There is another piece on the SA, the system agent side, that we didn't change. Well, the reason we chose not to integrate it is not because we cannot do it, it's because physically it wouldn't make sense. The SA, unfortunately, sits on the other side of the Intel CPU. So we have to use a PWM signal to loop around to drive it, which makes physical integration impractical. You would have a layout nightmare if we integrated that. That was the only reason why we left it unintegrated or disintegrated. It's because Intel CPU layout didn't help the case. However, even with that SA untouched, the total solution size is reduced by approximately 50%, and that's a huge premium on board space these days. People can either use a smaller machine size, or they can simply fill that space with extra battery size to extend battery life. Well, this application circuit is a little too detailed. I don't think I want to go into that kind of detail. The key is you can see that it's a It's a 4 by 4 millimeter CSP package. Remember, this includes 3 water rails with integrated FET and everything on 2 rails. The SA rail is just controller only. So all this is done with just a 4 by 4. As a comparison, if you do a discrete solution, let me go back to the previous page. If you do a discrete solution today, even from intersil and our competitors, the controller alone is 5 by 5. And that's just the control, not including the driver, not including the FET, and the controller alone is bigger than the PMIC. So the PMIC has a significant size advantage. When people have board space, they will simply find PMIC is their savior. All right, we go to, well, we already talked about this battery charger page. Let me go to here. So as we said earlier, we announced we launched another PMIC earlier this year in April. The part number is 95908. That is a subsystem PMIC powering the rest of the system. So with all 3 chips together, here is the block diagram on how to do an Intel Skylake platform. You would have a battery charger. You can pick which configuration you like, MEDC or hybrid. Then you put a 95852 core PMIC to power the Intel CPU. Then you have a 95908 for the rest of the platform. The rest of the platform, well, Intel doesn't really help us a whole lot by requiring 9 water rails in addition to the CPU rails. But the 95908 is able to address all 9 water rails with just one piece of silicon, with all the FETs integrated, all the control, including I2C, communication, fault monitoring, and all these things together. Therefore, if a designer chooses intersil solutions for his platform, the solution is super neat. What you get is just, well, inductors. That's pretty much it. All you need is just inductors and capacitors, and you put in our silicon. You have a super small board size, and this is your whole platform. That was why we, at the beginning of the presentation, we talked about having a full solution, because we realized how important it is to have a total solution instead of just pieces for different rails.
That's ideal. Very nice.
So as a summary, we have talked about our CPU core power solutions in a PMIC form factor that can reduce the board size significantly. And we have battery chargers that are very innovative and extend battery runtime. All these things are coming to the market right now. We're releasing all these markets into mass production. I think we have already released them, with the only exception that the subsystem PMIC was already released in April. And these, they are already available for orders. We can support customers who are interested in this. We do provide a lot of technical support in addition to any material, for example, data sheets, application notes. So we will help our customers do the right design to achieve their goal.
That's great. I really, really value these type of solutions. It just makes, you know, in this case for intersil, of course, being a good known and reliable supplier, Intel is comfortable with that. But the fact is that you have that whole solution. Really, it's critical to the performance of the systems these go in with their processor, and also the fact that you're supplying the entire solution, and that's kind of time to market for them. It's so, like you said, it's been kind of a stagnant industry for a while, but I think that's going to be changing a little bit. And I know I want I want one of these processors. I'm going to be asking my boss for a new computer. So
good to know that. Hopefully, I'll pick up a computer that has the intersil solution in it. Well, I can tell you, if you go buy a high-end computer, you have even better chances of getting intersil solutions, because all the customers that value performance, they have almost all chosen intersil.
So I'm telling my boss, it's like, I'll write articles quicker. That means more articles will come out faster.
That's right. Good one, Steve.
So I have an old ThinkPad, so, it's time.
Oh, yeah.
But this is great. I love these kind of solutions. I really, really think it's great for the industry. And, it provides everything that a company like Intel needs, really, for their next generation product. So that's really neat. Very, very good.
Good to hear that.
Yep, great. And I'll start working on this. I'll have it ready for, the end of this month. And, if you can just send me that other information, that'd be great. A little bit of information on
the R3.
Yeah, that'd be terrific.
All right. When would you like to receive that, Steve? 15 minutes or by tomorrow?
No.
Or
No, probably not even this week. Next week is fine.
Okay. So maybe we'll get it to you early next week.
Yeah, because it's the kind of thing I could be working on different parts of the.
Okay.
What I do is do a product review rather. We do lots of product introductions. Here's a new product, and it's almost like some of them are almost a copy of your press release. But what I do on EDN Power is I do a product review, and it's my opinion about the product, my opinion as to why I think it's important, and why it's important to the industry, and what it does for the industry, this kind of a solution. And it's nice to have that. Like I said, I value the full solution, I really do, and I think it's important to other companies out there who want to use these kind of power systems. So, and you guys are doing it right.
All right, appreciate it, Steve. I have a link in the PowerPoint to the 95908, the subsystem PMIC we launched in April. But I think I gave Vishal the Word document also if you need that. If you haven't received it and you do want it, I can shoot it over to you as well.
Okay, I'll let you know. I could probably grab all that stuff off your website too. So
Yeah.
That's not a problem.
Yeah. Like I said, I put a link, a hyperlink in this PowerPoint to the 95908 on one of the previous, actually slide 9 when we looked at the 3-chip complete solution. Yeah, right down there where it says introduced April 20th. April 20 is a hyperlink.
Right. Good. I'll use that. That's great. Excellent.
Okay.
It's a nice shortcut.
Yeah. I'm trying to make it easy for you, Steve.
I appreciate that because I probably need more hands. Maybe a couple of different computers because I've got a ton of backlog of things to do and so many great things to write about. So
Yeah.
But it's a lot of fun. I'm enjoying it. So, and I, like I said, I really like products like this, solutions actually.
Right. All right.
So good job.
All
Appreciate it. And thank you for the good presentation. Very, very wonderful and very clear.
Excellent. All right. Really appreciate your time as always, Steve. And we'll follow up with you. And, of course, any questions, let us know. We'll get back to you right away.
Sounds good. You guys have a good rest of the week.
All right.
All right. Thank you very much, Steve.
Take care.
All right.
Thank you.
Bye-bye.
Bye-bye.
So I mentioned to you, Jia will take care of